Good morning, team. We're going to start with General Chemistry, Chapter 2. We're going to talk about the periodic table. Just before we start, a quick note that I found in the textbook was about lithium, shown as Li. So it has an atomic number of 3. It's a soft alkali metal. It's the least dense solid with a specific gravity of 0.53. And it's a very reactive metal, and it's not naturally occurring. So we're going to fast forward to 2.1, which is the periodic table. We have elements A and elements B. So the way this textbook describes element A is that it's in groups 1 and 2 and 13 to 18. So these are representative elements, and their valence electrons are in orbitals s and p, as you may remember from chapter 1. For B elements, these are non-representative elements, and these include transition elements, which are S and D subshells, lanthanides, and actinide series, which are S and F subshells. In the periodic table itself, if you're going horizontally, so left and right, you're going to have what we call periods. So these are the different rows. So you're going to have period 1, period 2. Just know that the term period actually refers to rows. And the term group or families refers to the columns. And that was your 2.1. So moving on to 2.2, we're going to talk about the types of elements. There are 3 main ones, which is metals, nonmetals, and metalloids. So metals include alkaline, transition metals, lanthanide, and actinide. They're shiny, they're lustrous, they're good conductors of both heat and electricity, and they're malleable and ductile. That just means that they're easily bendable and you can just, if you apply pressure, you can change their shapes. And they easily give up electrons. Whereas nonmetals are predominantly on the upper right side of the periodic table. They're dull, they're non-lustrous, they're not shiny. They're poor conductors of both heat and electricity, and they're brittle in their solid state, so they can easily fall apart. And then you have metalloids, which are also called semi-metals, and they possess characteristics from both metals and nonmetals. And you can see them in the stair-step pattern. So if you look at the periodic table to your right there, you can see that I've circled those 3 types of elements in red. You have your metals in blue, your nonmetals in yellow, which is the upper right side, and metalloids in red that make that staircase pattern. So that was chapter 2.2, and we're going to go on to chapter 2.3, which talks about the periodic properties of the elements, where I've simplified the periodic properties, but we're just going to go through each one of them for better understanding. So we're going to start off with effective nuclear charge, also known as Zeph, with Z subnote of EFF. So it's a net positive charge experienced by electrons in valence shell. For example, if you have sodium, it has a positive charge, it's going to be -1. So Zeph increases from left to right, whereas the atomic radius is size of charged species, and cations are smaller and anions are larger. And atomic radius will increase if you go right to left and top to bottom. Just keep in mind that atomic radius is the only one that really stands out from the rest of the group. So whenever on the MCAT, you need to figure out how to do the atomic radius, just know that it is the opposite of pretty much all the other periodic properties. For ionization energy, it's the amount of energy necessary to remove an electron from the valence shell. And that increases left to right and bottom to top. So you just have to make an L with your left hand. You got your index finger facing upwards and your thumb facing to the right, and that's the periodic pattern that you will need for electronegativity, ionization energy, and electron affinity. Now the opposite pattern, once again, would be your atomic radius. So coming back to the definitions, electron affinity is the amount of energy released when an atom gains an electron from its valence shell. And the electronegativity is the ability of an element to attract bonding electrons to itself. So these three, including Jeff, increase with that L shape, and the opposite is true for the atomic radius. So moving forward, we're going to go to the next subchapter, which is the chemistry of groups, and we're going to talk about the different types of elements that we find in the periodic table. So starting with alkali metals, which is group 1. Remember, this is the vertical group, the first vertical group. So this has an oxidation state of +1. It has low Zeph and a low density. It prefers to lose an electron to have a noble gas-like configuration, so it's more stable. And these are the most reactive active metals. Next up, we have alkaline earth metals, which are group 2, so just right beside group 1. And their oxidation state is +2, and they're known as divalent cations. Divalent means 2 valence, and cations, if you remember from chapter 1, the T is a positive sign, so 2 positive. And these are also known as active metals, and they are the most reactive because they're trying to lose those electrons to gain that noble gas-like configuration. Next, we talk about the chalcogons, which is group 16. And they have an oxidation state of -2 or a +6, and that depends on if they're metals or non-metals. And they're biologically important, which include oxygen and sulfur, because a lot of these group 16 elements are used in everyday life. Oxygen with water, breathing air, other biological processes, and along with sulfur. So that's group 16. We're going to move to group 17, which is halogens, and these have an oxidation state of -1. And because it's -1, they prefer to gain an electron to achieve that noble gas-like configuration, which increases their stability. So they are opposite from the alkali metals in group 1, like we noticed before. Whereas alkali is trying to lose an electron, we have halogens that are trying to gain that 1 electron, so they make a perfect pair. And these halogens are nonmetals with the highest electronegativity. They're usually written as diatomics, so they're never written as by themselves. They're usually paired with each other. So diatomic would be F2 and Cl2, or you can also write them as anionic, which is just F with a negative sign, and Cl with a negative sign. Next up, we have noble gases, which is group 18. It's the last group, and it's a full-filled valence shell. So these are the most stable atoms you can find on the periodic table. They have high ionization energies and non-existent electronegativities and electron affinities. These are inert gases, so they're not reactive, and they have a low boiling point, and they're usually gases at room temperature. So coming back to the transition metals here, the only thing that the textbook really mentions is that they have multiple oxidation states. I have included the periodic table that was in the textbook, and you don't need to memorize all of the elements because a periodic table will be given on test date. But make sure that you are familiar with the different elements, the different kinds of metals, non-metals, their properties, etc. Thanks for joining me for Chapter 2, and I'll see you again for Chapter 3. Take care.